So today on Kicked Up Chemistry, again, we're going to be using fire, and these experiments can be very dangerous, so do not try them at home. With that, today we're going to be talking about combustion and combustion reactions. Now, very appropriately, I have my VP Racing Fuel shirt and hat on, just as a coincidence. Didn't really intend actually of doing it, but hey, if anybody from VP is out there and wants to sponsor our videos, that would be awesome. Now, whenever you talk about something burning, you have to talk about the energy released. And most people think of the energy in terms of calories and how many calories you have. How many calories will it take to burn off the food that you eat or that big slice of Portillo's chocolate cake? Well, the amount of energy in a calorie is the amount of energy required to raise 1 gram of water by 1 degree Celsius. Now, food calories are actually a very concentrated form of energy, so a food calorie is actually a kilocalorie. So if you eat something and it's 90 calories, it's actually 90,000 calories, which would be enough to raise 90 liters of water by 1 degree Celsius, which is quite a large amount of energy. So instead of burning race fuel or chocolate cake today, we're going to be burning gummy bears. Now, instead of just lighting a gummy bear on fire, watching it burn, it's not going to be very exciting. So what we're going to do is we're going to take it, we're going to fill a test tube full of a compound called potassium chlorate. Now, when you heat it up, it decomposes and generates a lot of oxygen. So we're going to be burning our gummy bear in almost 100% oxygen when it drops in there, which is going to look really cool. Now, the reason that we call this kicked up chemistry is because we like to take our reactions and kick them up. So here we have normal gummy bear, and here I have supersized gummy bear. So we're going to see what happens when we take this 18 times normal size gummy bear and burn it. Now it's like, hey, Professor Leonard, I don't think that your gummy bear is going to fit in the test tube. No. Not a problem. We have a big test tube, regular test tube, big test tube, which in its own right is a very cool kicked up apparatus. If you watched the intro to the lab part 1, I showed you the big test tube and I said, hey, we're going to be doing a really cool reaction and we'll have no problem dropping the gummy bear down into the great big test tube. Chlorate. Now, you got to go nice and easy and slow because if you heat it too much, there is a chance that it can explode. So I don't want that to happen, so I'm just gently melting it. Alright, now we got our molten potassium chlorate in there, decomposing into oxygen. Now I'm going to take and I'm going to drop the gummy bear into it. All right, wow, that was some reaction with that little bitty gummy bear. And again, according to the package, that was around 7.5, 7.7 calories. Well, gummy bears are made mostly of sugar, and that's what burned. And sugar, in this case, is going to be C12H22O11. Oxygen is O2. It's a hydrocarbon, contains carbon and hydrogen. So whenever a hydrocarbon burns, we get carbon dioxide and water as the products. Now let's go ahead and balance this equation. Alright, so now that the equation is balanced, we have for every 1 sucrose, it requires 12 oxygens, and it produces 12 carbon dioxides and 11 water molecules. Now, the big gummy bear, it says on the package it's 18 times the size of a regular gummy bear. So whereas the last gummy bear was a little under 8 calories, this one's going to be between 140 and 150 calories. So hopefully it's going to look really cool. All right, now that the potassium chlorate's all melted, we're ready to see what happens. Thanks again for watching Kicked Up Chemistry with Professor Leonard. I hope that you enjoyed our flaming gummy bears today. If you could, click that like button over here, click that subscribe button over here, so that way you'll be notified when new videos are uploaded. And thanks for watching.